The analog input-output modules are modules which connected to the analog devices or at the input or the output of our control system. So you can see here, this is the main difference. In the case of the discrete input-output modules, we said the device which is connected to the input-output modules are discrete device, so it has only two status, either on or off, 0 or 1. But in the case of the analog input-output devices, these devices can provide a wide range of data or a wide range of values. So, for example, it can be provide input from, for example, 0 to 20, 4 to 20, or 0 to 10 volt, as we already mentioned in chapter 1 when we talk about the sensors and actuators. So the analog input interface modules here accept this value, which is analog values, and it will be converted into digital value to be sent to the controller. We said the microprocessor only receive the digital values. So here we have the analog input modules. Here we have the processor. So this analog input module will receive the data from the transmitter or from the sensor here. This is ultrasonic sensor. Then this data will be sent to the processor, and the processor will process the data and send it to the analog output modules. So in the case of, since the output of or the analog output module is connected with analog device or analog indicator here, so we need to convert the data which go from the processor here from analog to, I mean, from digital to analog, then it will be sent to the analog output devices. So the analog output module here accept digital signal from the controller, then convert it into the analog to be sent to the analog device. So we can see here, the output device is analog, the input device is analog. For that, we need or we have to use analog input modules and analog output modules. The two basic type of analog input modules are voltage sensing and current sensing. We already talked before in chapter 1 when we studied the transfer function of the sensors, and we said, for example, some sensors they have the output from 0 to 10 volt, from 0 to 20 milliamps, from 0 to from 4 to 20 milliamps. So if the output of the sensor is from 0, I mean, is voltage, so we call it voltage sensing. If the output is current, we call it current sensing. We have here one example in this figure about the thermocouple. Thermocouple is a temperature sensor which measure the difference in the, or which measure the variation of the temperature and convert it into a voltage. So we said the input will be temperature, the output of the sensor will be voltage here. So this output voltage will be analog value, it's not a digital. So for example, it can be from 0 to 10 volt or from 0 to 1 volt. It depends on the rating or the range of the output voltage of this sensor. This output sensor or output voltage will be connected to the input module here. So analog input modules. So the analog input modules will receive the data from this sensor and from the another sensor. Then it will forward the data into the microcontroller. Since this data is analog, it should be converted into digital before sending to the microcontroller. So such analog modules should have analog to digital converter, which is one of the signal conditioning circuit that we study in chapter 2. So the main element here for the analog input model is the analog to digital converter. And we need to highlight here there is three types of the model for input models here. One is bipolar, which can accept signal, can change from from negative to positive value. So for example, the input signal can be changed from negative 10 to positive 10, negative 20 to positive 20. It has a negative and positive values. The other is unipolar, which has only accept the positive values signal. So it has only positive direction. So then we need to highlight, and the next concept we need to know is the resolution that we study in chapter 2 about the resolution of the analog to digital converter, which indicate how the our converter is accurate, or what is the reliability of our converter, and what is the value of the error for this converter. So unlike the input signal here, the current, I mean, for the in the case of the voltage, we said we have two type: voltage sensing and current sensing. So in the case of the current sensing here, the power or the it can use for longer distance. So if we have a sensor which is give you output as a current, not as a voltage, it can be connect for long distance or send the signal from the field to a long distance. While for the voltage, only for short, it can be used for the shorter distance only. So the current sensing here, the current sensing device, it can send the value or it can supply the power to the device. So here we can see the power supply is connected to the device, not connected to the module. In the case here we have type, we call it sensor supplied power. So the power is connected to the sensor, while the module here is get the power from the power supply of the CPU unit of the PLC unit. In the other type, we have the power is provided to the module here, and the module will send the power to the sensor, and we call it module supplied power. Usually we use twisted pair cable, like as you can see here, twisted pair cable here. So this twisted pair cable actually is used with the current sensing and voltage sensing devices. Actually, it's used to reduce the losses and also to avoid the interference, which may cause the noise for the received signal. We have this. This is show the transducer, and here we can see for the transducer that we talked before in chapter one. The transducer, we said it's a unit which or device which convert the energy from one form to another form. So, for example, here the sensor is a transducer which convert, for example, the input signal from temperature into output signal, which is a voltage. So this is we assume this is the block for the sensing unit or for the sensor, which have the sensor and at the same time it has the transmitter. So the sensor will sense the value of the temperature through this probe, and then it will send the data through the transmitter into the input module here. So this is analog input module. We said always analog input modules are connected with analog input devices. Analog output modules is connected with analog devices, while the discrete are connected with the discrete. Here we have different type of connection for the input or for the analog input modules. In the discrete type, previously we see each sensor is represented by one wire. So if the sensor is on or the switch is on, it gives you one. If the switch is off, it gives you zero. But here, since it is analog, so we used to have more than one wire, and we have other option. We can use two wire. We can use three wires. We can have also up to four wires. So we can see here this is with two wires. So one is that here is the transmitter, the power supply, and here the input modules. Then we have with the three wires here, we have one wire, two wire, three wires, and both are I mean the power supply, the input here positive, the input is negative. Since it is analog, so we have to connect into two terminals in the analog interface module. In the case of the discrete, you remember when we talk about the discrete, we only have like example terminal 0, terminal 1, terminal 2, terminal 3, and terminal 4, and so on. So each sensor or each switch connect with one terminal. But here we have each sensor or each input device is connected with in positive and in negative. Okay. Also, we have another type of connection. We may avoid to duplicate the wire for each sensor. So, I mean, we use for each sensor one wire, but all the negative sensor, I mean, the negative terminal of our analog interface will be short circuited into one analog, which is connected to the ground. So, all the common here are connected together into the negative of the power supply, while all the positive is connected to the positive of our sensors. The main element for the analog, as we said, the main element for the analog input module is the digital analog to digital converter, while the main element for the analog output module is the digital to analog converter. So in this module here, we need to convert from digital to analog because the output modules will receive the signal from the controller, which is digital, and it will send it to the analog devices, which is analog. So we need to convert it from analog to, I mean, from digital to analog. So the analog output here signal is varied under the control. For this figure here, we have this sensor, ultrasonic sensor, used to measure the level of the liquid inside the tank. Then this sensor is analog. It will send the signal to the analog input module here, and this signal will be current sensing from 4 to 20 milliamps. Okay, then this module will receive the signal is analog. It will convert it into digital, send it to the controller. The controller will receive the signal. It goes through the program inside for processing to take action and decision. Then it will send the output through the output module. This the analog output modules will receive the signal, which is a digital from the microcontroller, and then it will convert it into analog. Then it will send the analog output to the valve, since the valve is analog device. So the valve is analog output device. Ultrasonic sensor is analog input device. So the valve hand, when you receive the from the signal or the analog output from the controller, it will adjust the position of the valve. And we said, for example, some valves are proportional control, some valves are will change their position from 0 to 100%, either from close to open and so on, 10% open, 20% open, and so on. It depends on what is the level here. In the beginning, it will be fully open, so it will fill the tank. When the level of the tank is increased, this valve will be changed to uh, will start to close. When the valve is closed, actually, and this the level will goes. Uh, the signal that will be received from the analog output here will be stop the valve to become zero or to be fully closed. So we can see here this is the same example here to show you the level sensor, and we have here the valve, analog input and analog output. Is both of them, they go through analog input modules and analog output modules. So the valve is initially open. So initially open, that means it will fill the level will increase. When the level of this when the level of the liquid is increased to high level, for example, and the sensor will detect that the level of the tank is high, it will give update to the PLC. The PLC will send the signal to close this valve and stop the filling. So we have here some scaling actually, because as we know before, we said when we study about the transfer function, we said some input, some analog input from 0 to 10, some analog from 4 to 20, from 0 to 20 milliamps, and so on. So in order to do scaling for the, we need to define, for example, the minimum value, the maximum value, and so on. And based on a pre-calculated values, we need to define the highest and the lowest values. Okay, so here we have all this can be done through the software or through different instruction inside the ladder logic program of our PLC system. So here we just show you the scaling, how we can what's the definition of scale. Okay, then what is the engineering unit? Engineering unit can be, for example, temperature. We can use Fahrenheit, or for the length we can use the centimeter, and so on. For the transducer here unit, we can use the voltage or current, which is volt and milliamps. And we learn how to use the transfer function to convert the voltage, for example, into temperature, the current, the pressure into current, the speed into current, and so on. Okay. Binary row unit here, which is the value of binary unit, which is can be 1, 1, 0, 0, and so on. And this value actually will be generated from the analog signal by using analog to digital converter, as we see in the signal conditioning circuit. So here, this is the instruction that we call it scale with parameters. This one of the instruction that we or that exists in the ladder logic programming. Actually, one of the scale in this scale we need to define, for example, if we have some range for the temperature, for example, or for the pressure, or for any type of the input devices, we need to define the range. For example, this it has this temperature range from negative 100 to positive 200. So we need to define the minimum scale is negative 100, the maximum scale is 200 here. And also we need to define the minimum and maximum of the current, because this temperature actually will be converted either into voltage or current. In this case, will be convert to voltage from negative 10 to positive 10 volt, from negative 10 volt to positive 10 volt. So that means the positive 10 volt is equal to 200, negative 10 volt is equal to negative 100, and so on. And we have a scaling between these two values, and this scale is represented at the analog input models. For example, here from negative 32 to positive 32. Usually, we all these parameters will be defined inside the software of the ladder logic program, and this scale with parameter used to convert the imported values of the signal or of the that we that the microcontroller receive from the sensors or sent to the actuator, then is converted into digital value that will be understandable or readable by the microcontroller by the microcontroller. You can see here the negative 10 volt is represented by negative 32 main input, and the positive 10 volt is represented by positive 32. In between them, we have range of change to reflected by this function. So the same here for the SCB instruction or scaling with parameter instruction to scale the analog output. That one is the for the previous one is for the analog input here. For the analog input, since we are talking about sensors here, and the same is used with the analog output. So we need to scale the analog output in order to convert from digital values, which is received by the from the microcontroller, because the microcontroller you give you a digital value. This digital value will be converted into analog. This analog value will be sent to the device. So in order to convert from some scales like 4 to 20 milliamps, it will be converted to some values, range of values or number from 6,000 to 31 and so on. So all these just how to use this some instruction for scaling to convert, or for the transducer to convert the values from input value or raw data values into readable value by the microcontroller. We are going to continue in the next video.